So the first exercise of biasing is that we want to achieve a different curve from this basic one, which is like this. We want to achieve this curve. Now this says at 0 volts you have 10 hertz of biased. Alright, so the frequency starts from 10 hertz, not from the 0. And as soon as you increase the voltage at 8 volts, you will achieve 50 hertz. Now why? Because if you see, if your frequency is starting from 10 hertz at 0 volts, and we know that we have 5 hertz of jump at 1 volt, okay, because at 10 volt we have 50 hertz, at 1 volt you have 5 hertz. So at 1 volt it will be 15 hertz, at 2 volt it will be 20 hertz, at 3 volt it will be 25, and so on. At 8 volts it will reach 50 hertz. Alright, so let's see how to give this biasing. Now this bias adjustment is coming from this parameter, bias adjustment parameter 48, and there's a formula to calculate that. Now it says, formula says bias range, which is your 10 hertz divided by full range of frequency, which is your 50 hertz, multiplied by 100. So 10 divided by 50 into 100 accounts to 20%. So we have to give 20% in 48. So let's see. This is parameter 48. Here I have to enter 20%. So I have entered 20%. Now have a look at the frequency response. I'll go back to PLC. Now if D0 is 0, it means if it is 0 voltage. Oops, why am I doing D0? Yeah, K0. You will find frequency is 10 hertz. That's the biasing. Without giving any voltage, frequency is 10 hertz. This is what this curve says. Alright. When it goes to 8 volts, 8 volt is, if I go to PLC, 8 volt is like 32 bits, 3200 bits. K3200, you will reach 50 hertz. Before 4000, earlier we were getting 50 hertz at 4000, now we are getting at 3200 because we are getting a 10 hertz bias jump. Alright, so it will reach 50 hertz, and beyond 8 volts it will remain 50 hertz. It will not go beyond. So if I write 4000 even, it will remain 50 hertz. So my band of 8 volts to 10 volt is giving me 50 hertz. Alright, this is not giving any change in frequency, because maximum is 50 hertz. So that was about just biasing on this axis. Yeah, one more thing, if you're biasing on this axis, y axis, on frequency axis, bias polarity will be 0. This will be 1 if you're biasing on x axis. Alright, so what we have done is we have just changed the bias adjustment to 20% by this formula. Now suppose you want to start from 15 hertz, this should be from here, and this should be from here, 15 hertz. So in that case, what will be the bias? That will be 15 divided by 50 into 100, alright, which will be 30%. 30%. So if I put 30%, it will start from 15 hertz, and it may reach the voltage at 7 volts. Alright, it may reach the 50 hertz at 7 volts. So this is what we call biasing, right? How you can adjust the curves accordingly. Alright, so this you can do if you have a drive. You can practice by giving different biasing, and you can get different feedback curves. Not the feedback curve, but the biasing curves. Alright, so next video we'll see how we can achieve, how we can now in this case this is not working at all. 8 to 10 volt is not working. Suppose we want a biasing in such a way that we want to use full voltage range from 0 to 10, like that. At 10 volt it should be 50, at 0 volt it should be 10. So how we can achieve that? That we'll do in the next video. Right? Thank you.